The cold weather.
Oh.
Or throw them in the dryer.
That's what I'm doing.
Oh, you are?
Yeah.
Okay. Well, that's what I'm down.
Hey guys. How are y'all today?
You got the volume on? Your microphone.
I'm just going to go ahead and start working through the chapter test B that I handed out on Friday. unless anyone has any questions on any of the other assignments that I handed out first. Does anyone have any questions on those?
I do.
And
I do.
oh, you do? Which one do you have a question on, Eli?
2.8.
What? 2.8? Okay, let me get it pulled up. Was let's see. Was it on the worksheet that I handed out or the additional problems?
Worksheet.
Okay. The literal equations worksheet? All right, let me, I think that's on my regular computer, so I need to upload those files. So let me look for it real quick. Sorry. Some of those were a little tougher. Is this the one, Eli?
Yes, ma'am.
Is that it? Okay. Which ones did you have a question about?
I really need help, like, getting started with them.
Okay. So it says solve for W. So that means you're trying to get the W all by itself. So what is being done to the W? What operation is being done there?
It's being multiplied.
Yes, the L is being multiplied by to the W. How do I undo multiplication? What's the inverse
Division.
operation of multiplication? I think you said division, kind of broke up a little bit. So I'm going to divide both sides by L. So that's my final answer. A over L. Pretty writing, Miss Sparks. A over L equals W, so it's yellow. Does that make sense?
Yes, ma'am.
And then, okay, and then on this one, you're solving for R. And just like number 1, 2 and pi are being multiplied to the R. So to undo multiplication, it's division. So you have 2 pi R. So I'm going to divide that by 2 pi to get rid of it, because the inverse operation of multiplication is division. So I end with C divided by 2 pi equals R, because this just cancels. So it would be purple. And number 3, you're supposed to solve for big B. And once again, it's being multiplied, and the inverse of multiplication is division. So to undo the multiplication, you'll divide both sides by B. Or I'm sorry, H, because you're trying to solve for B. That cancels these two H's. So that leaves me B equals V over H. So orange. This one was a little trickier in that you have to first divide both sides by pi because pi is being multiplied by r. But then that would leave you a over pi equals r squared. And then you have to take the square root of both sides to get r all by itself. So I think I gave this answer out in class because it's r equals a over the square root of a over pi. For number 5, you're supposed to solve for p. And r and t are being multiplied to p. So you divide both sides by RT. So that leaves you with I over RT equals P. And for this one, you're supposed to get B all by itself. And to undo or clear a fraction, you multiply each side of the equation by its reciprocal. And the reciprocal of 1/2 is 2 over 1. So that clears your fraction on that side and leaves you 2a equals bh on this side. So to undo multiplication, it's division. So you divide both sides by h. And that gives you 2a over h equals b. So it's yellow. Is this helping, Eli?
Yes, ma'am. Thank you. Yes, ma'am. Thank you.
Yes. Is it making more sense?
Yes, ma'am.
So you'll be okay tomorrow? Okay. All right. So we're supposed to solve for W, and I think we did this. This was one of the guided practice problems as well as one of the equations on the 2.8 worksheet. So you're supposed to get W all by itself. So you have P minus 2L because you get to subtract 2L from both sides equals 2W. Then you'll divide both sides by 2. And that gets rid of the 2's on that side and leaves you a W. So you have P minus 2L over 2. And for this last one, there's multiple ways to do this, but you're supposed to solve to get H by itself. And I think I gave the answer to this one also. But you want to divide both sides by this B1 plus B2 because it's all being multiplied. So you would have A over B1 plus B2 equals 1/2 H. And once again, to multiply both, to clear the fraction, you multiply both sides by its reciprocal, which is 2 over 1. So your final answer is going to end up being 2a over b plus 1, which is green. So there's that worksheet. Now, for chapter test B, basically you were supposed to do the first 3 in your calculator and just watch your signs and be able to round. So if we think about the square root of, yes?
I had a question about question about 25 of 2.5.
A question on 3
Yeah,
through 5 on 2.5?
23, 25. I
On
got no.
2.5.
Yeah.
Okay, you were breaking up kind of bad on it. What was the assignment on 2.5?
This was page 107, 139 odd.
All right, let me pull it up.
Thank you.
Was that on practice A or on the work or the textbook?
The textbook.
Okay. And it was 23
Yes, ma'am.
and 25. Did it say no solution in the back of the book?
I didn't
Or
check.
did you look?
I just got no solution for both of them.
Okay, well, there is a possibility to get no solutions. I'll just have to look at the problems to see if it was.
I'll check the book.
Oh, I went way too far. I'm sorry, my other computer's really slow.
It's fine.
Miss Sparks,
Yes?
Mary Faith is trying to join
Yes.
the call, but she can't because it says she's blocked from this. I don't know.
It's blocked. What error is she getting?
Well, when she tries to join, it says you can't join this video call because one of the participants blocked you. I'm not sure.
Huh. I don't even know how to block a person. I don't know how to do that. I mean, I don't know how to undo that. Did somebody accidentally, hang on. Oh. I don't know. I don't know how to get her. I don't know how to make that not happen, unfortunately. Does anybody see where they may have accidentally blocked her? I don't know what, I don't know. I don't even know what to do about that. Sophia, are you the one trying to help her?
Yes, ma'am.
Bless you. And who was asking me? It is the answer to number 25 on 2.5 is no solution. What was the other one that you were asking about?
I ended up checking the back of the book. Both of them.
Okay, good. So you're good on that. So now we just need to try to figure out how to get Mary Faith in here.
Yes, ma'am.
I would think that I would be the only person that would be able to block. And I literally, if I did that, it's because I don't know what I'm doing and I accidentally did it.
No, we can block people.
I'm sorry.
We can block people, like the students.
You can? Hey, Annabella, can you tell me how to block people so that maybe somebody could go on and check and see how they could unblock them? How do you do it?
Well, I accidentally clicked on someone the other day and it said you could block them, but I didn't. But like I know you can block them.
Okay, and how? Okay. How do you click on someone? You click on their picture?
Yeah.
Okay.
If they have their like microphone on, usually it gives you like the option to like block them or mute them.
Okay. I don't know how. Okay. Oh, here we go. She joined. Are you good now, Mary Faith? Okay.
Yeah, she's good.
Okay. Can y'all see my screen?
Nope, we can't. You're not presenting.
Okay, thank
No.
you. Am I presenting now?
Yes.
Is it? So can y'all see the chapter 2 test B?
Yes.
Okay, praise God.
Yes, ma'am.
I'm like, because I'm like, whoa. I just learned all kinds of new stuff about Google Hangouts. All right, so the square root of 35, you would just put in your calculator and you should get roughly 5.9. Which it says approximate to the square root to the nearest integer. So I'm going to round to the nearest whole number, basically. But the reason why they say integer is if it's negative. Like on number 2, your answer is going to be negative 12.2, which means approximately 12. And when you plug in the square root of 18 into your calculator, the answer comes up to be approximately 4.2, which then you round to 4. Does 1 through 3 make sense to everyone?
Yes, ma'am.
Any questions?
Yes, ma'am.
Okay. Thank you for letting me know. Okay, now the area of town square is 14,400 square feet. So you're supposed to find the side length of the square. Well, since we're working on square roots, it makes sense to think that what you're going to do to find the answer to that is take the square root of 14,400, plug that into your calculator, and you plug in square root of 14,400 into your calculator, you should get 120. So the side length of the square is 120 feet. All right. Now, for problems 5 through 18, basically, well, 17 and 18, we'll have to set those up into equations. But for 5 through 16, we're just going to solve those just like regular equations. So I'm just going to start with number 5. I've got negative 7 equals negative 2 plus x. So to get x all by itself, I'm going to add 2 to both sides. And I get negative 5 equals x. And that's my answer. For number 6, I have b minus, and I know y'all loved this because it had a fraction in it, 2/5 equals 3/5. In order to get b all by itself, I'm going to add 2/5 to both sides. This is where you praise God that the denominator is the same, so you don't have to get a common denominator, right?
Miss Sparks, I can hear you, but I can't see you.
I
can hear you, but I can't see you.
You can't see me?
No, ma'am.
You can't see the board? Is there anybody else who can't?
We can all see it.
I can see it.
I can see it.
Okay. I'm going to try again, Mary Faith, and see if this works.
Now I can see you.
Can you see it now?
Now I can see you. Yes, ma'am. Yes, ma'am.
You can see it now?
Yeah. Yeah.
Okay, good. All right. So now I've got b equals 5/5, which that's the same as 1. So b equals 1. So that's number 6. Number 7 is negative 2/3 d equals 8. And to clear a fraction, you multiply both sides of the equation by its reciprocal. So the reciprocal is negative 3/2. So basically, this is the same as 8/1. So the 2, you simplify before you multiply. 2 goes into 2 one time. 2 goes into 8 4 times. And 4 times negative 3 is negative 12. And this canceled. So we have D on this side. So my final answer is D equals negative 12. Number 8, 17 equals 14 plus 6y. So I'm going to subtract 14 from both sides. And that's going to give me 3 equals 6y. I'm going to divide both sides by 6 because I'm undoing multiplication. And so 3/6 equals y. But that can be reduced to 1/2 equals y.
You want us to work these out?
So that's the answer for number 8.
You want us to work these out on a separate sheet of paper?
Yes.
Okay.
I mean, if you can do it on that paper and you've got plenty of room. But personally, I did a lot of mine on a separate sheet of paper. Some of them were simple enough that I could actually squeeze it in there. But some of these where I had to multiply by the reciprocals and stuff like that, there wasn't enough room. Does that make sense? So it was easier. Obviously, the square root ones at the top, I mean, those you didn't need to show your work much on that. And what I did on number 4, I just basically took the square root of 14,400. And that was easy enough to write right next to the word problem on the worksheet. But if I were you all, I would have had to have attached another piece of notebook paper. How many of you have already done a good bit of this and are just working through this to check your answers?
I've done all of them. I just need help on the two-word problem.
Okay. Good job. How are you doing so far? Not to.
I didn't get all of them.
Oh. I love the feedback. That's always my favorite. On number 9.
On number 8 is
2t
0.5. Okay.
Number
8 is 0.5. Okay.
Yes, yeah, that's okay. Just one of the things that you're going to want to get used to is when we move into slope, decimals don't work for slope because it's rise over run. So you just want to make sure that you're getting used to working with fractions and being able to reduce them quickly.
What did you get on number 4?
That's in the. I'm sorry.
What did you get for number 4?
The answer to number 4, 120.
Okay.
Miss Sparks.
Yep, you take the square root of 14,400. Yes.
Why did we write number 2 as positive 12 when integers can include negative?
Number 2 is negative because of the negative sign out in front of the 150.
Oh, I thought at the beginning you said to make it negative. Like, sorry, positive. Write it as positive.
Oh, write it as positive or negative?
Mm-hmm.
That's only when you're solving for x.
Okay.
When you see on something, this is called the natural square root of 49. But if you have a problem that looks like this is looking for all the possibilities that the square root can be. So that would be plus or minus 7. But this, on the other hand, there's an assumption that you're just looking for the positive one or the natural one. Does that make sense?
Yes, ma'am.
But what the differences are? Okay.
Both types of those questions on the test tomorrow.
I don't think there are. I will double check and I will warn you in class if there are to watch it. Okay.
Thank you.
But I think it's more like this test. So it'll be like if they want you to write, they might have something like this on the test. It might be plus or minus 64.
Yeah.
So in that case, you would write plus or minus 8.
All right. Thank you.
So on those, when you're just finding the square root, you want to really watch for whatever sign is in front of it.
Okay.
Good questions, though. Great questions. Any more questions over 1 through 4 and the square root stuff?
Do we need to memorize
which I'm sorry, say that again. Do we need to memorize what?
Like the vocabulary, I guess. Like natural numbers will include 0 and things like that.
No, you don't need to memorize that for definitions. I'm not going to have any definitions or anything on there. It's just knowing what to do. If you come when someone asks you for the square root and you're given a problem and it's just like, you know, the square root of 25 or the square root of 81, you would just answer 5 and you would just answer 9 on that. But if the problem looked like that, then you would have to do that. The only thing I'm asking you to know is to know the difference between those two types of problems. But I'm not going to ask you to memorize what does the natural square root mean or anything like that. There won't be any vocabulary. Does that answer your question? Or are you asking me if you need to know your square roots? I mean, it's always a good idea to know your square roots all the way through 25, but I'm not going to put any hard ones on there, and you are going to have access to your calculator. The test is much like the chapter test B, except it's a little easier. I always give the harder thing for the review to make sure you know it.
Miss Sparks.
So on number, yes.
So I have a question about some of these literal equation ones. I still cannot seem to figure these out.
Okay, are you talking about from the coloring worksheet?
Yes.
Can I get through this and then go back to that? Because I already went through all of them. So but I will go back through those. Again, were you here for that? Because I did that at the very beginning. You may not have been here for that.
Got that from Publix.
Oh, okay. Well, I will absolutely go through those with you. And I'm happy to do that. And I will also send you the answer key for it, but I'll be glad to go through that. But let me get down to through these, and then we'll go back to that.
All right.
Okay. It's great questions, and obviously you're not the only one struggling because I already did go through that, and it is a little bit more of a hard concept, but it's definitely something you need. So we'll get to that. For number 9, you're going to combine like terms, 2t minus 5t. So that gives us a negative 3t equals 9. And then you're going to divide both sides by negative 3 to get t all by itself because you're undoing multiplication and negative 3 is being multiplied by t. And I'm saying a lot of this because this is very important to be able to transfer these same thoughts into those literal equations that we're working on. 9 divided by negative 3 is negative 3. So the final answer for number 9 is t equals negative 3. Number 10 is 13 minus 9w equals negative 14. And we're going to subtract 13 from both sides. And then we have negative 9w equals negative 27. And the negative 9 is being divided by or it's being multiplied to the w. So we're going to divide. That's the inverse operation of multiplication. And that's going to leave w equals negative 27 divided by negative 9 is a positive 3. So number 10 is w equals 3. Number 11, 7m minus 4 minus 2m equals 6. We have some like terms on the left-hand side. Yes?
Back to number 9.
You have a question? I'm sorry?
I think I did something wrong here.
You have a question on 9?
Yes, ma'am. I did,
okay.
I did, for t minus 5t. Where you just do t times in parentheses. And then I did 9 over 2 minus 5.
So you did it like this.
Yes, ma'am.
So then you can solve inside the parentheses.
Oh. I just divided both sides by 2 minus 5.
Then you divide. Okay. So then if you did that, let me go back.
Right, you would get positive 3.
All kinds of fun ways to do algebra.
I'm messing these up. Oh boy.
Miss Sparks, I can't see
So that crosses
you.
that
I can't
out.
see you.
And then you got 9. And then 2 minus 5 is 3.
Mm-hmm.
Negative 3. And t equals negative 3. Mary Faith, you can't see me again?
No, ma'am.
And then I tested it and got no.
I don't know what.
Work out.
So you checked it. I don't know what's happening, Mary Faith, with yours. Let me.
Now I can see
Can
it.
you see it now, Mary Faith?
Now I can see it.
Okay,
Miss
so
Sparks?
if you check it back in and you put a
Miss
negative.
Sparks?
Yes?
I have a question on 12 and
Yes?
14. I have a question on 12 and 14.
Okay. All right. I'll get to those after these, but who was asking me about number 9? When you checked -3 and put it back in, it didn't work?
I mean, I checked +3, but I figured out that it didn't.
-3 doesn't work either?
-3 does. Positive.
Is that what you said?
-3 does.
Oh, okay. Okay. All right. So, all right. So is everybody good on 9, 10, and 11 then?
Yes.
Oh, I need to do number 11 still.
Yes.
Okay. Is there anybody who needs me to do number 11? Does that mean everybody's got number 11? No problems?
Yes, ma'am.
Because I can do it quickly. So everybody knows to combine like terms when they're on the same side and all that good stuff. Well, good.
Yes.
All right. So number 11 is m equals 2. And so I'll move on to 12. And 13. There are several ways to do number 12, actually. And I've got it on my paper. I have it worked both ways, but there's actually even more than the 2 that I have. But I'm going to show you my favorite way first. And then I'll show you the way that the other way works consistent. The way that works consistent is if you distribute that 3/4 all the way through. But what I want to talk about, especially because we're dealing with all these literal equations that seems to be tripping people up, understandably so. But when we're looking at this, we know that 3/4 is being multiplied to this, the c plus 4. So to undo multiplication, which I'm still within the order of PEMDAS, because technically this c plus 4 in parentheses is a grouping, which is at the top of PEMDAS. And remember, we're undoing PEMDAS. So we can do the multiplication and division before we handle the parentheses and exponents. And so to clear a fraction, you multiply both sides by its reciprocal. So over on this side, I would multiply 3/4 by 4/3. And whatever I do to one side of an equation, I have to do to the other. So this clears the fraction on this side and leaves me with c plus 4 equals, and then this side leaves me with 4. And I'm going to I'm going to undo the adding by subtracting, which leaves c on that side and gives me 0. But if, on the other hand, you had distributed the 3/4 and you got 3/4 c plus, if you multiplied 3/4 times 4/1, you would have gotten 3. Subtract 3 from both sides, and you get 3/4 C equals 0. You multiply both sides by the reciprocal. Leaves you with C on this side, and 0 times anything is always 0.
Is this number 12?
So there's 2 different ways to work out number 12. I'm sorry?
You answered my question. This is number 12, right?
What was your question?
My question. This is number 12, right?
Yes. That was 2 ways to do number 12. And whichever one makes most sense to you is how you should do it. But those are 2 different ways to think about it. And there's probably a third. It's the fun thing about algebra, but what you want to do is just make sure that you're following all of the algebraic principles, the identities, just like you would want to do on those literal equations. You're looking at them and trying to decide what is being done to undo something. That's what you're doing. And you're doing the same exact thing when you're working with the ones that have numbers as well. Okay? Okay, we're getting ready to start on number 13. Five times 3 minus 2y plus 4y equals 3. Now, unlike number 12, where there's only one thing being multiplied, we can't start with the division here. We actually have to distribute because of this. Because I know once I distribute this 5 to both things inside the parentheses, I can see that I'm going to have some like terms to combine. So I've got to distribute this 5 to both things inside the parentheses. So 5 times 3 is 15, and 5 times a negative 2y is negative 10y plus 4y equals 3. Now I need to combine my like terms, which is a negative 10y and a positive 4y. So that's going to give me 15 minus 6y equals 3. So now I'm going to subtract 15 from both sides of the equation to undo the addition there. And that's going to leave me a negative 6y equals negative 12. And now I'm going to divide both sides by negative 6 because to undo multiplication, I divide. And now I have y equals 2 as my final answer for number 13. Any questions about that? Excuse me. You know my dog. Come on, yes. Come on. Sorry about that. Just make sure tomorrow when y'all are taking the test that you are taking it slow and working out each step. Don't skip any steps, and watch your math. Take cautions. Take your time. Number 14, 4x minus 1 equals 2 times 2x plus 3. All right, I need to distribute on the right side of the equation. The 2 times 2x is 4x, plus 2 times 3 is 6. And now I want to combine like terms. So I'm going to subtract 4x from both sides. And that leaves me with a negative 1 equals 6, which is not true. So that is no solution.
I kind of did it opposite of that. I kind of did it opposite of that. I did the constant to both sides, and then I got 0 equals 7.
Okay, that's fine.
I got negative 7 equals 0.
Yeah, I
got negative 7 equals 0.
Well, I didn't finish it out, so I can see where at this you all worked it all the rest of the way out, which is awesome. I could have actually if you probably combined your constants first. So if I actually did this, added 1 to both sides, then I would get 0 equals 7. But I just stopped here because I ran out of. But probably what happened is y'all dealt with your constants before you did your variables, which is fine. Does that make sense?
Yes, ma'am.
What I'm talking. Okay, all right. But it's no matter how you look at it, it's no solution, and that would be what I was looking for. Because whether you deal with the constants or the variables first. Because like I say, what could have happened in order for that, what might have happened is that y'all added 1 to both sides before you dealt with this. Does that make sense?
Yeah.
Okay. But either way, it's fine. However you did it, you came up with the fact that 0 does not equal 7 or negative 1 does not equal 6, and it's no solution. So that's what I would be looking for. Number 15. 7a minus 3.9a equals 6.2. So you need to subtract 7.9. So that's going to give you 3.1. 3.1a equals 6.2. Then I'm going to divide 3.1 on both sides, and that's going to leave me a equals 2. Number 16, 9 minus 5z equals 12 minus 6z plus 7 in parentheses. The tricky part here was technically on that right-hand side, you have to distribute the negative all the way through, like this was being multiplied by a negative 1. So it's like negative 1 times 6z gives me a negative 6z, and negative 1 times 7 would give me a negative 7. So now I'm going to combine like terms. Sorry about my messy writing here. My Z's are hard to. And then 12 minus 7 is 5 minus 6Z. And then I'm going to, add or subtract a 9 from both sides. So that's going to leave me a 5Z equals negative 4 minus 6Z. I'm going to add 6Z to both sides. And that leaves me Z equals negative 4 as my final answer. How are you all doing so far?
Good.
Excellent.
Good.
Excellent.
All right. Glad to hear it. And like I say, this is harder than the test. So if you make it through the review, you should be good to go on the test. Just remember to take your time tomorrow.
Thank goodness.
Yes.
I just need time to check my work.
Not bad at all. Yeah.
Yep.
Okay, getting ready to start on number 17. It's a word problem, so I'm going to start reading it while I'm erasing the rest of the work here. Number 17 says a new plasma screen television costs $5,250. A family makes a down payment, so the cost is $5,250. They're making a down payment of $552, and they're going to pay the rest of the balance off in 24 equal monthly payments. So the down payment plus the 24 equal monthly payments have to equal this $5,250. So this is the equation. The first part was to set up the equation. And what we knew was how much the TV costs, plus the down payment, plus we knew that there were going to be 24 equal payments, but they wanted to know what is the monthly payment. So you knew there had to be 24 of those. So to solve for that monthly payment, you subtract the payment that they had from both sides of the equation, and that would give you $4,698 equals 24x. Divide both sides by 24. And that gives you $195.75. On number 18, on a class trip, there were 45 more girls than boys. The total number of students on the trip was 211. Write and solve an equation to find the number of girls and the number of boys on the class trip. So we don't know how many there were of either. But what we do know is that there were 45 more girls than boys. So if we set the boys equal to X, then we know X plus 45 is the girls. The other thing that we know is that these two combined or added together would give you the total number that went on the trip, which was given in the problem as 211. So now we got to combine like terms. And now we've got a nice algebra problem that we're pretty used to solving. Subtract 45 from both sides. We've got a 2x over here. We have 83 boys, or 83 equals x. So that was the boys. And then 83 plus 45 is 128 girls.
I got the same answer at the end, but I wrote my.
'How did you write it?
45 plus x equals 211. 45 plus x equals 211.
45 plus x?
Yes, ma'am.
Can you scroll down, please?
This way? Or this way? I don't know how you would have gotten the same answer without having two x's.
I don't really know how. I wrote my work.
Because you need to have a representation. You would have had to have a representation of both the boys and the girls.
I just got x and then I added 45 to x.
Okay, so if I'm understanding correctly, it was 211.
No, I did 200
x plus 45.
No, I did 211 minus x equals 45 plus. 211 minus x equals 45 plus.
Oh, you did 211 minus x equals x plus 45?
Yes, ma'am.
Is that what you did?
Yes, ma'am.
Oh, okay, that's cool. That's interesting how you thought of it, but that basically it's the same thing. I get it. I understand what you're saying.
Okay.
Great. If that's how you saw that, that's fine. I totally understand your reasoning. So you basically subtracted the number of boys from the total number, and you set that equal to the number of girls.
Yes, ma'am.
So that's fine.
Yes, ma'am.
That's fine.
It was just
That's the beautiful thing about algebra. A lot of times there are different ways to set up equations. That's for sure. But that's great. I like the fact that you had your own unique approach. That's wonderful.
Bye, Miss Sparks.
Bye, Mary Faith. Yes, who's asking? Who just said Miss Sparks? It sounded like Sophia, was it?
Yeah, I have to go
Okay.
soon. I had a question on a page that we did sometime last week.
Okay.
And
what was the question?
2.8. Is the practice 2.8?
Okay. I think
Number
I
20.
actually have that one pulled up, believe it or not.
Number 20.
I anticipated that. Oh, no, I don't. Wait a minute. Let's see. This one?
No. Wait.
Is that it?
Yes. No. Wait. Yes.
Okay. Which one?
Number 24.
Did you have a question about?
Number 24.
24. It's not even showing up on mine. I think you only had to go to 20. Oh, there it is. You only had to go to 22.
Oh, okay.
On that. But I'm proud of you for moving on.
I think we went to 20. Oh.
And I actually, hey, Sophia, I will actually do that one with you in class tomorrow or on Friday, if you like.
Yes,
to make sure that you understand it, because I love that you tried to work it on your own. Okay?
All right.
But you only had to go to 22 on this worksheet. So did you get to that point?
Yes, ma'am. Yes, ma'am.
Okay, great. Perfect.
Thank you. Thank you.
Oh, you're welcome. Thank you. All right. Are there... I know that we've been here a bit. So if there's others of you, is there any specific questions, or do you want me to just list the answers so that you all can check them? For
25 and 26.
20.
25 and 26.
I'll do 25 and 26. How about if I list the answers to these and y'all could be checking those, and then I'll do 25 and 26. And I will do these. I'll work these out. But I'm going to write the answers first.
If you write the order of positive, negative differently, will it still be accepted?
Yes. Are you talking about if you wrote number 25 like this? If you wrote 25 like this, and you wrote 26 like this.
Yeah, I meant, yeah, like that.
If you wrote either of those like that, that is acceptable too. Just the key thing is, remember, every sign has a number and every number has a sign in algebra. So I will be checking for the signs, not the order.
Okay.
Okay. All right. Has everybody had an opportunity to check those so that I can go ahead? I'm going to work out number 25 and 26, and that will kind of help too if you're struggling with some of the literal equations. That'll help with that as well. But I will work out number 25 and 26. And then Patrick, if you've been so kind as to stick with me through this, I will get to those literal equations with you also.
All right, thank you.
Uh-huh. How's everybody doing with regard to the answers on this? Everybody okay?
Yeah.
Okay, good. Sounds like y'all are ready then.
I'm not.
Oh, you don't feel ready?
No.
Oh, bless your heart. How did you do on this part?
On what part?
On the chapter test B.
I mean, the square root thing, that was easy, and the solve the equation if possible on the first couple were easy for me, but after that, it kind of got a little bit harder as you go down.
Yeah. Well, I will say the ones on the test are a little easier, but I tried to make these a little harder to test every which way that equation can be written and all the different ways that you have to work out the combinations. So hopefully that was my reason for doing that, because if you make the review a little harder, you know, sometimes it's easier for the test. Okay, on this one, what we want to do to get y by itself, we're eventually going to move that 7 over, but we have to distribute this 1/3 first. So we're going to distribute 1/3 to the x, and then when you distribute 1/3 to a -9, it kind of looks like this. So simplify before you multiply. So that's going to give me a -3. So I've distributed that, and now I'm going to add 7 to both sides. And that gives me y equals 1/3 x plus 4. Number 26, 4x minus 6y minus 8 equals 0. Trying to get y all by itself because that's what function form is. So I'm going to add 8 to both sides because I've got to get most everything except for the y over to the right. So that's going to leave me 4x minus 6y equals 8. And now I'm going to subtract 4x because the understood sign in front of the 4 is a positive, and to undo a positive is a negative. So now I have -6y equals 8 minus 4x, or if you wrote it the other way, minus 4x plus 8, that's fine too. Now I'm going to divide both sides by -6 because to undo multiplication, which that's what's going on. This is a -6 being multiplied by a y. So you divide. Whatever you do to one side of an equation, you have to do to the other. So now I've got 8. Basically, I've got 8 divided by a -6, which is basically 8 over -6, which reduces to 4 over 3. Help me, Lord Jesus. -4 over 3. And then I've got a -4 over 4x over -6, which is going to be a positive 2/3 because a negative divided by a negative is a positive. So my final answer is this. Or it could be written the other way, which is y equals 2/3 x minus 4/3. Either way you write it is fine. Any questions? So function form is getting y all by itself. Okay? All right, now I'm going to go back through the literal equations on the coloring, unless anybody has any other questions on any of the other worksheets, because I know they're all due tomorrow. So some of you, which is fine because it's probably good review anyway, some of you might be going through those worksheets and reviewing them or finishing up a few problems here and there. So if you have any questions on other worksheets, this is a good time to ask. Or I think I even had some additional book work, which were like 11 through 19 out of the book, which those were all getting the equations into function form. If you have any questions on those, I could answer those now. If not, Patrick had asked earlier about the coloring activity, so I'm going to go through that again. And I think what I'm going to do this time is I'm going to toggle between, because I think trying to, and Eli, if you're still there, this might also help a little bit, because I feel like I kind of jumbled the equations up a bit when I was working on them with you. So maybe it'll help to see them written out bigger. Whoops. A equals L times W, and you're supposed to solve for W. So that, which means you're getting W all by itself. So whatever is being done to W, you want to undo or do the inverse of in order to get it all by itself. And right now, W is being multiplied to L. And the inverse of multiplication is division. So I'm going to divide both sides by L. So that leaves me with A over L equals W. So my final answer is W equals A over L, or yellow in this case on the coloring worksheet. On the next one, C equals 2 pi r. And we're supposed to solve for r, which means you're supposed to get r all by itself. So what is being done to r here? It's being multiplied by 2 and pi. And to undo multiplication, you divide. So I'm going to divide both sides by 2 and by pi because they're being multiplied to r. So that means I can cancel over here, and just like we wanted, r is all by itself. So C divided by 2 pi is my final answer. So purple. Number 3, I'm supposed to solve for big B. So V equals big B little h, and solve for B. And what's being done to B? Well, B is being multiplied by h. And to get B all by itself, I want to divide or undo the multiplication that's going on. So that leaves B all by itself. So it's V divided by H equals big B, which is orange. Patrick, is this starting to make a little more sense?
Yes, I was fine on the first 3. It's just when it puts the exponent in there, that exponent kind of confused me.
Oh, yes. That was a little bit of a tougher one. You're absolutely right. And I felt when you I felt like I gave the answer, but maybe I didn't in your class. And I would never put one like that on there, but I do want to expose it to you because you will have that in geometry and you will have that in algebra too. So I'm trying to at least expose a little bit of that stuff to you guys. Because it'll come back. So A equals pi r squared, and we're supposed to solve for r. So A equals pi r squared. And we're supposed to solve for r. So first things first, because we're doing PEMDAS in reverse, I have to deal with the multiplication before I ever get to the exponents because they're toward the bottom anyway. So I'm going to divide or toward the top of the order of operations, and I'm working them in reverse. But I am going to divide both sides by pi. So that leaves me a over pi equals r squared. And to undo an exponent, and in this case, it's a square, so I would take the square root of both sides. So I have the square root of a over pi equals, and then the square root of r squared is r. So for that one, it's red. R equals the square root of a over pi. So Patrick, do you need me to do 5?
Yes.
Okay.
That's also one of the ones.
So number 5 was 2?
Yes.
Okay. So I believe, well, let's see. I won't even bother to erase that. I'm going to keep it there. That way. Number 5, this was 4. Number 5 says solve for P. And you've got I equals P, R, and T. And I'm supposed to solve for P. Well, P is being multiplied by R and T. And to undo multiplication, you divide by R and T. And whatever you do to one side, you have to do to the other. So I divided by R over T equals P. So it's blue.
Okay. That makes sense.
That makes sense? Good. All right. Number 6 is solve for little b. A equals 1/2 BH. Did I write it right? Yeah.
Yes.
So I want to solve for this right there. So first of all, what I want to do, because I've got a lot of multiplication going on, but I'm going to clear the fraction first. And how you clear a fraction, even in a literal equation, is the same way that you would do it in a regular equation. You're going to multiply both sides by its reciprocal. And the reciprocal of 1/2 is 2 over 1. So I'm going to multiply both sides by 2 over 1. And that gets rid of the fraction. And over here, that leaves me 2a, because 2 times a, and this would be a over 1. So then now I've got bh on this side. And I'm solving for b, and so b is being multiplied to h. So to undo multiplication, I divide both sides by h. So 2a over h equals b. And that's yellow. And then number 7 is one that was on the guided practice. We've done this one a few times. P equals 2L plus 2W. And we're solving for W. So we're going to subtract 2L from both sides. And that gives me P minus 2L equals 2W. And 2, we're trying to get W by itself. It's being multiplied by 2. So we get our final answer, which I'm going to have to write over here, is P minus 2L over 2 equals W, which is blue. And then for the final one, do you have a question?
No, I'm trying to tell my friends to shut up one day.
Oh. I need to give myself some room on this last one, so it's taking me a minute to get this erased. But did this help going through this?
Yes.
Okay, good. I know the literal equations, you really will use these, but I know they can be kind of tricky. But just remember, we're doing the same things. It's just all letters, which has a tendency to be a little freaky looking at first. We've got A equals 1/2 H. And then B1 plus B2. All of this is multiplication. It's just uglier multiplication. So what you could do, and I don't even remember what I did first time on the last one, but the first thing, if you wanted to, you could get rid of the fraction. So you could multiply both sides by 2/1. Because all of this, believe it or not, is multiplication. You just have a grouping going on at the same time. So that makes it look a little uglier as one of your multiplications. Because I feel like, what did we have to solve for? Was it H? Yes.
Yes.
All right. So now you have H being multiplied by a grouping. And remember, a grouping, when you're working PEMDAS in reverse, is this last P, or the parentheses are grouping. So it's the very last thing to be dealt with, but it has to be handled together. So you're actually going to divide this whole thing by the grouping itself. By the grouping, which cancels here, and it leaves us our H cancels here, and it leaves us our H all by itself. And then your final answer is this 2A over B1 plus B2, which is green. Which is green. I'm sorry?
Is everyone else hearing Miss Sparks? Really?
Do I sound weird?
You sound like a...
Do I sound weird?
You sound like really, really weird.
Oh. That makes me sound like a demon. Is it just the math that makes me sound like a demon?
No, like actually that's like what you sound like coming through. It's weird.
Let's see. I'm not sure how I can, I'm not sure. I think sometimes.
Hold on, I'm using Bluetooth audio, so it may be that.
Oh, okay.
Reset that.
I don't know. Let's see if I sound better.
Yeah, you sound better on my computer, so let me try to reconnect
Okay.
the headset. Hurry up, thing.
Okay.
Come on, you Bluetooth, hurry up. Okay, there we go. It's reconnected.
Okay. So oh, good. Do I sound better?
Yep.
Okay. So the final answer on that one is 2A over B1 plus B2, or green.
All right.
Okay.
I
So
feel a lot
there's
better about that.
Okay, good. But there are all the answers for that worksheet all in there. And then I'm going to go ahead and fill in. I know that I did these, but I'm going to fill this in.
Some of the stuff I'm just finding like random pieces of paper that have answers on them, but yet I don't know what the answers go to.
Oh,
It's
okay.
very hard to figure some of these out. So I've kept them together. I have them together. I'm just not positive that I have them.
Oh, you just like didn't write down what it went to?
Yes. should have, but
Oh, okay.
most of these I've got them all stapled together to their work, but some of them. So on this one that was it's from a while ago. What do frogs wear on their feet in the summer thing? Is that due?
Yes.
It's like, okay, I need to finish that then. I don't know why it's not finished, but okay. That doesn't look hard.
Yeah, I think it was a riddle one, and I can't remember. I can pull that up in just a second, but I wanted to make sure. I'm sorry?
The multi-step equation maze.
Yes.
That's due as well.
Yeah, I can pull up.
And error analysis, solving two-step equations, and also are the action cards or like the QR code cards also due?
Yes, that actually looked like, if I'm not mistaken, that was the 28. Like I gave a piece of, let's see, I'm trying to think.
Yeah, I have it somewhere.
Are these the same thing?
The classroom 28 QR code task cards and worksheet. There was a worksheet that had just the 28 on it, like blanks where you could write in the answer. And that's, a lot of people are using that with their work stapled to that.
This, right?
But see, hang on just a second. Let me switch back over because when I'm toggled onto this screen, I can't see.
Yeah.
Yes, that's it.
Okay, cool.
Who showed that just now?
Katie.
Oh, hey, Katie.
Hey.
Yes, that was it. If everybody can see what Katie just shared, that's what that thing looks like.
What thing? Wait. Well, I was still going through here trying to find some of this stuff. I'm like, wait, what?
Katie, do you mind showing it again?
Oh, yes, that thing. I do have that done.
Yeah. You could.
What do I need? Oh, I need this thingy.
I'm just making a pile of things to do because I've got some things that are not.
Well, I was going to say sometimes, I wouldn't recommend always waiting to the last to get it done, but sometimes having just a few on every worksheet isn't really all that bad. If it's just a few, I wouldn't want anybody to be overwhelmed with what they have to do, particularly because I always give a review, because I want you all, because the test will look like this format. The chapter test B will look like that format. So I want y'all to at least be familiar with what the test is going to look like. But
these action QR code card things.
Yes.
I have them all stapled together. But
that's fine.
I don't have any answers on them. And I remember doing it. So I'm gonna have to find where
well, it's probably in your note card or your notebook somewhere then.
Yeah, probably.
Yeah, okay, I did that.
Yeah, I just have to pull folder in my binder with paper.
And like you said, hopefully you'll know which ones they are. Like when you going back through your stuff, obviously that's why I put the date on there. So maybe if you were dating some of your papers, you could look for that date like right around 8/15.
Yes. Flipping through my whole paper section right now. I do have an old paper section stack that I took out, and that may be in there, so I'm gonna have to look. This looks like it's important. And the 30th looks like page 137 through 138, 47.
Yeah, this would have been earlier on. This was even before our first quiz. So.
I guess I'm just gonna have to look around.
Yeah. Are there any other questions over that stuff? Because I need to move on to Algebra 2 Math Lab. But if somebody has a question, I want to make sure that I get to that. Or if there's a question that you have, Ella, let me put up for you.
All right, I'm good, I think.
Okay. I don't know how long you've been on there, Ella, but if you want to, you can check your answers against this real quick before I go. And then if you have any questions.
All right, thank you, Miss Sparks. I've got to go get on this stuff because I haven't completed any subjects yet today. So.
Uh-oh. Well, good luck to you, Patrick. Thanks for coming to Math Lab. We'll see you tomorrow.
All right, bye.
So how are you today, Mrs. Sparks?
I'm doing pretty good.
It's good.
Ella, are you getting it checked?
Yes, ma'am. Thank you.
Okay. No problem. Tell me when you're ready for me to move it down.
Okay, can you move it down a little bit more?
Yes, ma'am. Absolutely. And what I did on number 25 and 26, the ones in the answer blank are written one way, and the ones that are under each problem, number 25 and 26, are written the other way, and either way is acceptable.
Okay, thank you. I'm done checking them.
I'm sorry?
I'm done checking them. Thank you so much.
Okay. How did you do?
Pretty good, actually.
Yay! Well, this is harder than the test, so
Okay.
you should be good to go. But this is the same format that the test will be in.
Mm-hmm.
And so that's why I try to make my reviews look like my tests.
Okay.
Okay?
Yep, thank you.
All right. Well, if nobody has any other questions, I'm going to move on to Algebra 2. But I love you guys, and I hope y'all had a wonderful weekend. I look forward to seeing y'all tomorrow.
See you tomorrow. Bye.
Bye-bye.
Bye.